tutorial I will show you how to install and use the Sentinel Pipeline graphical interface. This tool is designed to process Sentinel-1 and Sentinel-2 satellite data starting from a selected area of interest or AOI. The workflow allows us to search and download satellite products, crop them over the AOI, prepare clean time series products, extract statistical indicators, and finally compare either different AOIs or different management zones, such as M1 and M2. The goal is not only to download satellite images, but to transform them into organized temporal indicators that can support agronomic interpretation. To make the tutorial easier to follow, I will use a short 1-month time window. This makes the processing faster and allows us to go through all the main steps without waiting too long. First, I open the terminal. Now I create the main project folder. Then I enter the folder. This folder will contain the graphical interface, the Python scripts, the configuration files, the downloaded data and the final outputs. Now I create a Python virtual environment. A virtual environment is a separate Python workspace used only for this project. This is useful because all the required libraries will be installed locally inside this project without modifying the global Python installation. Once the environment has been created, I activated it. As you can see, everything worked correctly, so this means that the virtual environment is active. Before installing the libraries, I upgrade pip. Now I install the Python libraries required by the pipeline and by the graphical interface. This step can take a few minutes. These libraries are used for different parts of the workflow. For example, Streamlit is used for the graphical interface, NumPy and Pandas are used for numerical operation and tables, Matplotlib is used for plots, Rasterio is used to read and write raster data, and Shapely and PyProj are used for geospatial operations. When the installation is complete, if the terminal still shows the virtual environment at the beginning of the line, we can continue. Now I create the folder that will contain the Python scripts. Then I create the folder called configuration folder. Inside the config folder, I create two files. The config.json file contains the project settings such as the AOIs, the time period, the Sentinel-1 and Sentinel-2 parameters, the output folders and the management polygons. The credentials.json file contains the credentials required to access the satellite data service. For security reasons, credentials should not be shown in public video. Now I create the Python scripts inside the scripts folder. Finally, I create the graphical interface file in the main project folder. Now I open the project folder in the File Explorer. The structure should look like this. I open each file and paste the prepared code. First I open config.json, pass the configuration code and save the file. So, and I save it. Then I open credential.json, pass the credentials and save the file. After that I open each Python script inside the script folder, pass the corresponding code and save each file. Finally I open GUI.py, pass the graphical interface code and save it. At this point the project structure is ready. Now I go back to the terminal, I make sure I'm inside the main project folder and that the virtual environment is active, then I launch the interface. You enter your email, then the interface should open automatically in the browser. If it does not open automatically, you can copy the local URL from the terminal. The interface is organized into different tabs. The first tab is Manage AOIs. Then we have Download, Prepare Filter, Statistics, Compare AOIs, and Compare M1 versus M2. The logic of the workflow is sequential. First, we define or select an AOI, then we download the satellite data. After that, we prepare the data and generate clean time series products. Finally, we run statistics and comparisons. It is important to note that download and preparation steps do not need to be repeated every time. Once the data are already downloaded and prepared, we can repeat the statistical analysis and comparisons directly. In the first tab, I can manage the areas of interest. An AOI is defined using a bounding box with minimum and maximum longitude and latitude. For example, I can define a new AOI by entering the new name, min and max longitude and latitude. After pressing the button to add the AOI, the interface saves it inside config/config.json. Once the AOI is saved, it becomes available in the drop-down menus of the other tabs. In this version of the interface, AOIs are added as rectangular bounding boxes. More complex polygons or management zones such as M1 and M2 must be defined manually inside a configuration file. Now I move to the Download tab. Here I select the AOI, the time windows, and the download mode. For a first test, I use a short time window, for example from January 1st to January 31st, 2024. I keep the mode as dry run. The dry run mode is very useful because it checks whether Sentinel-1 and Sentinel-2 pairs exist for the selected AOI and time window without downloading the actual data. Now I press Run Download. Correctly, I can now run the real download. I change the mode from dry run to download. Since satellite zip files can occupy a lot of disk space, I can activate the option to delete zip files after cropping. This means that the original zip files will be removed after the useful cropped zip files have been created. This step may take some time because the tool connects to the satellite data service, downloads the products, pairs Sentinel-1 and Sentinel-2 acquisitions, crops them over the selected AOI, and stores the results in the output folders. When the process is finished, the output should show Done. After the download, I can inspect the output folders. The logs folder contains CCV files describing the paired Sentinel acquisitions. The worksets folder contains the data organized by AOI and time window. In fact, here we can see Angers apple orchards. Then we have the temporal windows. Inside each time window, we can find Sentinel-1 and Sentinel-2 folders, cropped products, preview images, and pairs.ccv files. The pairs.ccv file is important because it stores the information about matched Sentinel-1 and Sentinel-2 products. Now I move to prepare filter. So we have prepare filter. This is one of the most important steps in a workflow. Here the tool transforms the cropped satellite products into organized time series products. For Sentinel-2, the script uses the SCL layer to mask clouds, cloud shadows, snow, and invalid pixels. For Sentinel-1, the script applies a SAR filter to reduce speckle noise. Then it computes optical indexes and radar indicators. Examples are NDVI, GNDVI, and so on. I select the AOI and I keep the SAR filter as refined Lee with a filter size of 7. Now I press Run Prepare Filter. When this step is complete, the tool has created the analysis-ready time series products. If the groups and variables do not appear immediately in the next labs, I refresh the Streamlight page. So here you can see fishy series, Angers, apple orchards, and here you have what we have already done. For example, you have the sequences of indexes, so in this case NDVI. Now I move to the statistics. tab. This step extracts statistics from the prepared raster time series. For each data and each variable, the script computes values such as mean, median, standard deviation, minimum, maximum, percentiles, number of valid pixels. For a first test, I select only one variable, for example, NDVI, and I keep videos disabled to make the process faster. Now I open the output folder created by the statistics step, which is this one, time series analysis, and I can see the site and the various indexes. So for example, in this case we have plots. I'll show you an example. And you will also have videos, which for now I just didn't download. Here you have tables, and here you have further information about statistics. Then, if I want to compare two different AOIs, I just go here, I choose the two sites I want to compare, which right now I just see no common prepared groups found because we have not downloaded Anger Spear Orchard yet. But once you do it, you will just find in the output AOI comparison with all the statistics and videos and plots of the comparison between the two AOIs. The last comparison option is the M1 versus M2 comparison. This is used when the one AOI contains two internal management zones. The M1 and M2 polygons must already be defined inside the config.json. I select the AOI, the groups, and the variables. Again, for a fast test, I select one variable and keep videos disabled. The command is, as you can see, the preview. And for example, I will choose S2. No videos, run. This step extracts separate statistics for M1 and M2. So we go in time series analysis and we will find management comparison. And for example, if I go to the plots, we can see both the managements and the delta, which is the difference between the two managements. It is important to understand that not every step must be repeated every time. If the data have already been downloaded, I do not need to download them again. If the time series products have already been prepared, I can directly run statistics or comparisons again. This makes the workflow faster when testing different variables, different time window, or different comparison settings. To summarize, the complete workflow is first we create the project environment and install the required libraries, then we prepare the scripts and configuration files. After that, we launch the graphical interface. From the interface, we can either select an AOI, search and download Sentinel-1 and Sentinel-2 data, prepare clean time series products, extract statistics, and compare either two AOIs or two management zones. At the end of the workflow, the raw satellite acquisition have been transformed into structured temporal indicators that can support agronomic interpretation.